Bismillah ar-Rahman ar-Rahim. Assalamu alaikum dear students. I am Mr. Sanaullah Khan, lecturer in Computer Science, Institute of Computing, Cohort, University of Science and Technology, Cohort. I am the instructor of course Data Science CS 325. Today I want to deliver lecture number 9. The topic is Naive Bayesian classifier. These are the recommended and reference book: Introduction to Machine Learning with Python, and second one is Introduction to Machine Learning. These are the outline. Today we want to discuss, first of all, to discuss the probability, and then conditional probability, some Bayes rules, how it can be derived, and then naive Bayesian techniques, some example of naive Bayesian classifier, and then some task and summary. So what is a probability? Normally people use the term probability many times each day. Let's suppose a physician says that a patient has a 50-50 chance of surviving a certain operations. Another physician may say something that she is 95% certain that patient has a particular disease. So while in daily life nothing in life is certain, in everything we do, we estimate the chances of successful outcomes, from business to medicine to the weather. So a probability provides a quantitative description of the chances or likelihoods associated with various outcomes. So it provides a bridge between descriptive and inferential statistics. Let's suppose this is a population and this is a sample. Population is the combinations of sample or whole population about some data, about relevant data is called as population. Let's suppose population of peoples, population of shoes, and population of birds, population of fruits, etc. Sample is the some output from these population, some collection from these population is called as sample. So using the probability, we collect sample from the population, and then using some statistical properties or methods to analyze the sample, and then we predict on the basis of this sample, and we decide about the take decision about the total population. Let's suppose we want to predict a COVID effect on the population, and then we take some sample of peoples. It may be male, females, old, and kids. After using taking their test and using some statistical methods, if the test is more of the people having test positive relevant to this population, then we can say that the whole population is affected. If in the sample number of the students, number of the peoples which are limited, their population is low, their test is mostly negative, then we can say that the whole population is not affected. So an experiment is the process by which an observation or measurement is obtained. So an event is the outcome of these experiment, usually denoted by a capital letter. Like we throw a die, then it is an experiment. Outcome of the die, result of the die is called as an event. So the basic element to which probability is applied: when an experiment is performed, a particular event either happens or it does not. So experiments record an age. Person is a 30-year-old. B, person is older than 65. Or another experiment, toss a die. A, observation, observe an odd number. Second, B, observe a number greater than 2. So two events are said to be mutually exclusive if when one event occurs, the other cannot, and vice versa. So experiment, toss a die. Events A, observe an odd number. B, observe a number greater than 2. C, observe a 6. D, observe a 3. Now we want to check which one is mutually exclusive and which one are not mutually exclusive. So these two are not mutually exclusive, because observe an odd number, observe a number greater than 2. If it is odd number 3, so a 3 number is also greater than 2. They are connected with each other. While these two are mutually exclusive. No, we want to check what is the condition of B and C. Are B is mutually exclusive with C or not. So please students, try these two, B and C and B and D. So an event that cannot be decomposed is called as sample events, denoted by E with subscript. So each sample event will be assigned a probability measuring how often it occurs. So the set of all sample events of an experiment is called the sample space. So these are, let's suppose an example that I toss sample events will be 6. So their combination is called as sample. Then this is called as sample space. The probability of an event A measures how often A will occur. We write probability of A. Suppose that an experiment is performed n times. The relative frequency for an event A is number of times A occur divided by total number of n. So equal to F divided by n. If let n gets infinitely large, then we use the term probability of A limit n tends to infinity F divided by n. Probability of A must be between 0 and 1. If an event can never occur, probability of A is equal to 0. If an event always occur when the experiment is performed, probability of A is equal to 1. The sum of the probabilities for all sample events in S is equal to 1. So the probability of an event A is found by adding the probabilities of all the sample events contained in A. So probability can be found using estimate from empirical studies, common sense estimates based on equally likely events. Example, toss a fair coin. Then how we can find the probabilities? The probability of head in this coin is 1 over 2, because if we toss a coin, there are two options. It may be tail or head. So the probability of tail is also 1 over 2. Suppose that 10% of the US population has red hair. Then for a person selected at random, then what is the probability of this person? So red hair is 1 over 10%, means 0.10. So example, toss a fair coin twice. What is the probability of observing at least one head? So if we toss one coin one time, then there are two probability, head and tail. If we toss a second coin, the probability may be extended. So the probability of second time toss is head, first head, second head, yet possible first and second tail. First tail, second head, first tail, second tail. So combined probability look like this. The two coin toss may be head, both head, one first head, second tail, first tail, second head, and both tail. So this can also contain at least one head, also contain at least one head, also contain at least one head, while this event never contain any head. So probability of at least one head, probability of event 1 plus probability of event 2 plus probability of event 3, and probability of event 4 is not involved because they contain no head. So the result is 1 over 4 probability of event 1, 2 and 3, 3 by 4. Bayes theorem. Bayes theorem named after Rao-Thomson Bayes. It works on conditional probability. So what is meant by conditional probability? Conditional probability is the probability that something will happen given that something else has already occurred. So using the conditional probability, we can calculate the probability of an event using its prior knowledge. So probability of conditional probability, the probability that A occur given that B event B has occurred is called as the conditional probability of A given B, and is defined as probability of A given B is equal to probability of A intersection B divided by probability of B if probability of B not is equal to 0. Coin toss and fair dice example. Let's start from the basic by understanding conditional probability. When you play a fair coin, there is an equal chance of getting either heads or tails. So you can say the probability of getting head is 50%, i.e. 1 over 2. The probability of getting a 1 when you roll a dice with 6 faces. So assume the dice is fair, the probability of 1 is 1 over 6 because each event is having a chance of 1 over 6 in a single dice. So playing card example, let's suppose you pick a card from the deck. Deck contains 52 cards. Can you guess the probability of getting a queen that the card you have picked will be queen? Condition is this, given that the card is spade. So spade already occurred. After that we check the probability of queen. Well, I have already set a condition that the card is spade. So the denominator eligible population is 13 and not 52 because the queen include in these spade card will be selected. Since there is only one queen in spades, the probability it is a queen given the card is spade is 1 over 13. So toss a fair coin twice definedly. A, head and second toss, head on second toss, head on first toss. So find the probability. So if we toss a coin 2 times, so this is the probability of each one. So probability of A given B is 1 over 2. So probability of A not given B is 1 over 2 also, because it may be head on first, it may be head on second. So probability of A does not change whether B happens or not. A and B are independent. So what is meant by independent? We can redefine independence in terms of conditional probability. Two events A and B are independent if and only if probability of A given B is equal to probability of A or probability of B given A is equal to probability of B. Otherwise they are dependent. So once you have decided whether or not two events are independent, you can use the following rule to calculate their intersections. So multiplicative rules for intersection is, for any two events A and B, the probability that both A and B occur is probability of A intersection B is equal to probability of A and probability of B given that A occurred is equal to probability of A and probability of B given A. So if the events A and B are independent, not dependent, then the probability that both A and B occur is, condition will be changed. The probability of A intersection B will be equal to probability of A and probability of B. So in certain population, 10% of the peoples can classified as being high risk of a heart attacks. So 3 peoples are randomly selected from this population. So what is the probability that exactly one of the 3 are high risk? So define H means high risk, N means not high risk. So P exactly one high risk, the probability of in 3% maybe first person is on high risk and 2 are not. Maybe the second one is on high risk and first and third were not. Maybe the first 2 are not on high risk while the third one is on high risk. So probability of high risk and probability of non-high risk, probability of not high risk. So probability of high risk is 0.9 because in 10% maybe. Probability of not high risk may be 0.9, and then total probability is equal to 0.243. Suppose we have additional information. In the previous example, we know that only 49% of the population are female. So also of the female patients, 8% are high risk. A single person is selected at random. So what is the probability that it is a high risk female? So define H high risk, F define females. So again by formula from the example, probability of F is equal to 4.9 because total females are 49%. Probability of H given F is equal to 0.8 also given. Use the multiplicative rules. Probability of high risk female is equal to probability of H intersection F. So probability of F and probability of H given F is equal to this. Conditional probability. So when you say the conditional probability of A given B, it denotes the probability of A occurring given that B has already occurred. Mathematically, conditional probability of A given B can be computed as probability of A given B is equal to probability of B given A multiplied by B and divided by probability of B. So here A and B are two events set up outcome of independence. P is the symbol to denote probability. So probability of A given B, the conditional probability that event A occur given that B has occurred. It is called as posterior probability. So probability of B given A, the conditional probability that event B occur given that A has occurred. So likelihood of the training data. So probability of A, the prior probability of the response variable, it will be known on the basis of the events. Probability of B, the probability of training data are the evidence. So the Bayesian rules, Bayesian rule is way of going from probability of X given Y known from the training data set to find probability of Y given X. So we replace A and B in the above formula with the feature X and response are class Y. For observation and test or scoring data, the X would be known while Y is unknown. For each row of the test data set, you want to compute the probability of Y class given the X has already happened. So what happened if Y has more than two categories? If it is a binary classification, so we compute the probability of each class of Y of both classes, yes or no, and let the highest win. In which probability is more highest, then we say that it is put in this class. So probability of Y given X is equal to probability of X given Y into probability of Y divided by probability of X. The variable Y is the class variable, means play golf or play not golf, which represent if it is suitable to play golf or not given the conditions. Variable X represent the parameter or feature. X is given as X is equal to X1, feature 1, feature 2, feature up to feature n. So represent the feature I, they can be mapped to outlook like feature 1 outlook, feature 2 temperature, feature 3 humidity, and feature 4 windy. So by substituting for X and expanding using the chain rule, we get probability of Y given all features is equal to probability of X1 given Y, probability of X2 given Y, probability of Xn multiplied by probability of Y divided by probability of X1 and probability of Xn. Now you can obtain the values for each by looking at the data set and substitute them into the equations. So for all entries in the data set, the denominator does not change because it remains static. So therefore the denominator can be removed and probability can be introduced. Proportionality can be introduced. So probability of Y divided by feature 1 up to feature n, and it can be written as probability of Y from I is equal to 1 up to n and P of xi given Y. So in our case, the class variable has only two outcomes, yes or no. There could be cases where the classification could be multivariate, means more than two classes. Therefore, we need to find the class Y with maximum probability. So using the above function, we can obtain the class given the predictors. Suppose that there are m classes C1 up to Cm given in unknown data sample X, i.e. having no class label, means it is used for testing purpose. So the classifier will predict that X belongs to the class having the highest posterior probability given X. So if a probability of Ci, class Ci given X is greater than probability of class Cj given X, then X is assigned to Ci, otherwise assigned to Cj. This is called as Bayesian decision rule. In the Bayesian classifier, we just say see the probability of each class and then compare. When the probability of one class is greater than from the other, then we can put the test data into this class. Example, this is a data set. This is the training data. This is the feature, outlook, temperature, humidity, wind and class. There are basically two classes, yes and y, means golf will be play or not. So in this training set, the probability of y is 9 by 14 because total 14 items, where 9 is yes and 5 are no. Now we want to check the probability of each feature with given class y. So probability of outlook in the probability of xi given c. So probability of sunny with class y. So sunny are totally 1, 2, 3, 4 and 5. Now we want to check with y, sunny of n, not with y, again n, sunny is again n, sunny y, and second one sunny is also y. So means sunny in x feature sunny given y is equal to 2 by 9. So probability of sunny with n is equal to 3 by 5. Same is the case probability of overcast. So total number of overcast is 1, 2, 3 and 4. Now check overcast with class y. So 1, again 2, 3 and 4, means total 4 overcast associated with class of y. So overcast given y is equal to 4 by 9. Again overcast given n is equal to 0 because total is 4 and no one will be associated with n. Again we want to check a temperature. So probability of heart. So check it, heart 1, 2, 3, 4. Total number of heart is 4. So heart with y, it is with n, and this is one is with y, this one is with y. So total number of heart is 2 divided by 4, and with 2 is associated with y. So 2 is also associated with n. Melt, check it, 1, 2, 3, 4, 5 and 6. Total number of atom temperature melt is 6. So associated with y, 1, 2, 3 and 4. So 4 is associated with y. Probability of melt with n, total is 6 and 2 remain, 2 is associated with n. So probability of cool 1, 2, 3, 4, total is 4. Now check with y, 1, 2 and 3. So 3 by 9, so 1 by 5. Same is the case of humidity. Probability of high with y. So high is total 1, 2, 3, 4, 5, 6 and 7. So with y, 1, 2, 3. So 3. Probability of cool with high with y is 3 by 9. So with n is also 4 by 9 because total is 7. Probability of normal 1, 2, 3, 4, 5, 6, 7. So with y, 1, 2, 3, 4, 5 and 6. So y 6 by 9, while with n 1 by over 5. Same probability of windy with y 3 by 9, with n 3 by 5. Probability of true with y 3 by 9. So true, check it, 1, 2, 3, 4, 5. So 5 with y 1, with y 2, with y 3. So 3 by 9 with n 3 by 5. Same as the case of false, 6 by 9 with n 2 by 9. So now we get the probability of each event. Now if there is an event, unseen sample is coming, his parameter is like this. His parameter is rain, hot, second temperature is hot, third humidity is high, and wind is false. If this is, let's suppose, the testing purpose data, then what is the probability that it will be y or n? So for the probability of x given y into probability of y is equal to probability of rain given y. First we will calculate this probability multiplied by probability of hot given y, probability of high given y, probability of false given y. So probability of rain given y is also given. Probability of rain given y is 3 by 9. Okay. Probability of hot given y, hot 2 by 9, already calculated. Probability of high given y is 3 by 9. Okay. Probability of false given y is 6 by 9. So after calculating, multiplied by probability of y, which is 9 by 4, it gives probability this. So for the n, x power x given n, so rain given n, hot given n, high given n, false given n. So probability of rain given n is 2 by 5. Probability of hot given n is 2 by 5. Probability of high given n is 4 by 5. Probability of false given n is 2 by 5. So multiplied by probability of n, which is 5 by 14, multiply. So sample x is classified in class n, means today don't play a golf. Why? Because probability of n is maximum as compared to probability of y. So this is the Bayesian theorem. Task 1. If this is the training set, this is the feature, age, income, student, credit rating, and class is by computer, no or yes. This their binary classification problem. So C1, class 1 is by computer yes, class 2 is by computer no. So data sample is, if it is unseen data, age is less than or equal to 30, income is medium, student is yes, credit rating is fair. So what is the probability that this student buy a computer, yes or no? So compute probability of x given Ci for each class. For age, its probability is this. For age less than, buy computer with no is this. For income medium, buy computer with yes is this. For income medium given by computer no is this. Same for student, yes, no. Same for rating, same for age less than income. So after calculating the probability, we can say x belong to class by computer yes, because the probability of yes is maximum as compared to probability of no. Another task, dear students, please try to solve this task using this data set. This is the feature name over 170 cm, eye or hair length, and sex. This is the classification to classify that the person is male or female if at having these attributes, these feature. So data sample is, name is Drew, over 170 centimeter no, eye is blue, hair length is long. So what is the probability that Drew is a male or female? So what is the probability being called Drew given that you are a male? So this is the little bit case study assignments. Check. It has a zero conditional probability problem. For a feature having zero frequency, the total probability also becomes zero. How to fix this problem? Another disadvantage is the very strong assumption of independence class feature that it makes to find such datasets in real life. Summary: in today's class we discussed the introduction to basic probability, then conditional probabilities, then Bayesian, how to derive a Bayesian rule, and then Bayesian theorem. After that we also discuss some example and also a task for the students. Thank you so much for watching the video. Inshallah we will meet again in another class relevant to the course. Thank you so much.